Okay, in this recording, we're going to be looking at integrals that yield inverse trig functions. Okay, so we're going to be looking at these two examples. So I think right now I'm just going to erase that second one. We'll just start on the first one. Now, before we get started, let me just say something about calculus students. The university where I teach, you need to have a prerequisite of an algebra class before taking calculus. And I find time and time again, and I'm sure it's the same everywhere, calculus students tend to forget a lot of algebra that they need. One of them is factoring, which actually doesn't play a part in this video, but the other one is rewriting things using the exponent rules, and that's definitely something that we're going to need for this video. Now also, I've got up here, you can see just some standard formulas. So it depends what your teacher, what your professor will allow. If they give you a formula sheet for a test or a final exam, or if you're expected to memorize stuff like that. But I just have it there. I'm going to use it for this video. Okay. So when I'm looking at this, the first thing that I notice about these templates is, that I've got a u squared in those templates there, okay? And this I think is going to fit in with this one, okay, because I have a square root, so this one here doesn't have a square root involved, and there's no term out the front of this square root like there is there. So I'm going to try and make this match that form. It doesn't exactly, so I'm going to have to use a bit of substitution. But before I do that, I'm going to need to manipulate that. In particular, I'm going to rewrite x to the fourth as x squared all squared. Okay. Now here, a squared is 1, so I'm going to take my a to be positive 1. So a is, yes, plus or minus 1 all squared is 1, but a is assumed to be positive. Okay. So I'm going to rewrite this. I'm going to move that 2x out to be with the dx. So I'm going to rewrite 1 as 1 squared and then minus x squared all squared. Okay, so that's the algebraic reasoning I'm using there for rewriting. And now I'm going to do u substitution. In particular, I'm going to let u be x squared. Then if I take derivatives of both sides, then the derivative of u with respect to u is going to be equal to the derivative of x squared with respect to x. And now you can see how this is going to work out nicely. So this will become 1 over the square root of 1 squared minus u squared du. And now I can just do the template. And, oops, sorry. I've already done that. This is just going to be equal to arc sine of u over a plus c. So since a is just 1, it's going to be arc sine of u plus c. And this is a correct answer, but at the very end you have to write everything in terms of x. And so I still have this in terms of u. So your professor would expect you to take it further. And so u is equal to x squared. Okay, so now I'm done. And it depends on the textbook you use. Older textbooks will write arc sine because of the typesetting way back in the olden days. Or it could be written just as an inverse trig function. So either one of those is a correct answer. Okay. All right, so that's our first one done and dusted. Let's look at the next one. Okay, the next one is we want to see if we can find this one. Okay. All right, so just scanning these templates over here, I'm definitely going to try and make it fit into that one, okay, because it's got the square root in the denominator, but it also has a term out the front. Okay. Now, I do need to do a bit of rewriting. And the rewriting, again, is algebra. 9 is a perfect squared, so I can rewrite it like that. And using the exponent rules, that's the same as 3x all squared. Okay. And 4 I can write as 2 squared. Okay. And so I can frame it like this. Now I'm going to use u substitution, and I think we can see I'm going to let u be 3x. Then if I take derivatives of both sides, I'm going to have that. Okay. Now I just have a dx there. So if I divide both sides by 3 or multiply both sides by a third, it's the same thing. So if I multiply this by a third, it goes away, and I have that. Okay, so that's going to be that. Okay. And then finally, it's shaping up nicely. I just need to deal with this. Okay. And I can, again, if I divide both sides by 3 or multiply both sides by a third, I'm going to have that. And so this becomes 1/3 times u. Okay. So I might put that 1/3 du in the numerator. And then instead of x, I have 1/3 u times u. Then the square root of u squared minus 2 squared. Okay, now you can see where the 1/3s cancel. And now I have rewritten it to fit this template. So using the template, so the a is going to be 2. I'm going to have 1 over a, so 1/2, times arcsecant of the absolute value of u over a, which is 2, plus c. Now I need to write this in terms of x. And so u is 3x. And I can drop the absolute values if I stipulate, and you might have it stipulated at the beginning of the problem. So if x is strictly greater than 2/3, okay, and that's fine as an answer, or if you're used to writing inverse sequent instead of arcsecant, you can have it written like that. So sometimes at the beginning of the problem they'll stipulate, you know, that x is strictly greater than 2/3, in which case you can drop the absolute value symbols. Okay, but you do have to qualify it if you haven't been told this here. So you just can't drop absolute value symbols willy-nilly. Okay, so I have stipulated if that were the case we could drop them. If you weren't told any better, then that's the generalized version. Okay. All right, so I'm going to stop the video there. I've got lots more videos on different topics, so you can check them out, but I'm going to stop this one here for now, so thanks for watching.